Hello everyone, welcome to Vardhaman College of Engineering. My name is Dr. Ramesh Kumar Gajula, working as Assistant Professor in the Department of Chemistry. Today I am going to discussing about the very interesting chapter in engineering chemistry, that is polymers. Polymers are also known as larger molecules or macromolecules. So here in the name only the definition will be there. Polymer. Here the word polymer is derived from a Greek language. In a Greek language, poly mean many and mers mean parts or units. So mono mean single unit, but here poly mean many and mers mean parts or units. With these words, I am going to explaining the definition of polymer. Polymer mean the combination of many units is known as polymer. Mean here the polymer is going to made up of with the combination of many units. So that's why what happened, the weight of polymer is going to increasing. So that's why the polymers are known as larger molecules. So here polymer is a macromolecule. It is formed by the repeating units, or also that repeating units are known as monomers. So these repeating units linked of large number of smaller molecules and linked with strong covalent bonds are called polymers. Now here the polymer, Hermann Staudinger scientist was the father of polymer chemistry. He made the significant contribution in the polymer material chemistry. So these are the various polymeric materials we are going to use in our daily routine lives. So this is the examples of polyethylene material, and these are the examples of polyethylene terephthalate, polyethylene acrylate materials, and these are the examples of PVC materials like PVC windows, okay, carry baggage, and this is the polyurethane materials, and these are the polystyrene examples, and these are the polypyrrole materials. So various polymer materials we are going to used in our daily routine life. So that's why it is going to very useful materials in our life. Next one, moving to polymerization. So during this process, the formation of polymers are called polymerization. Mean the process in which the monomer units are combining together, it gives polymer. So that's why this process is known as polymerization process. So here I am going to synthesize one simple polymer, that is the polyethylene molecule. N moles of ethylene monomers molecules are undergoing polymerization. It gives polyethylene molecule. So this process is known as polymerization process. And next one, degree of polymerization. So degree of polymerization mean how many number of monomer units are involved in the formation of polymer is called degree of polymerization. So here if I am going to synthesize the polyethylene molecule with 500 monomers of ethylene molecule, then the degree of polymerization of this polyethylene is equals to 500. So that means the number of repeating units or monomeric units present in a polymer chain is called degree of polymerization. Next one, classification of polymers. So we already know one classification, that is the based on the origin. Polymers are classified into two types. They are natural polymers and synthetic polymers. And next another classification is based on the degree of polymerization. Polymers are again classified into two types. They are oligopolymers and high polymers. Oligopolymers mean whose degree of polymerization is less than 600. Whose degree of polymerization is less than 600 are called oligopolymers. So these polymers does not play a major role in engineering properties because this polymers material possesses less strength. So that's why this material cannot be used in engineering property applications. And the next second one is high polymers, whose degree of polymerization is greater than 600 is called high polymers. So these polymers are going to used in design engineering applications because these materials are going to possess high strength and also lightweight along with good flexibility, special electrical properties. So that's why these materials are going to used in various engineering applications. Next one, another classification is functionality of the monomers. Here, before going to classification, here I am going to explain the definition of functionality. So, functionality mean the number of reactive sites or binding sites present in a monomer is called functionality of the monomer. The number of reactive sites or binding sites in a monomer is called functionality of the monomer. So, based on this number of active sites or binding sites, then the functionality of the polymers is classified into three types. They are bifunctionality, trifunctionality and multifunctionality of the monomers. Now, if two reactive sites are present in a monomer is called bifunctionality. So, this bifunctional monomers always gives the linear straight chain polymer material. If three reactive sites are present in a polymer is called trifunctional monomer and it gives the branched chain polymer structure. For example, if the number of reactive sites or binding sites if greater than 3, then it gives the network structure or three-dimensional structure of a polymer. So this is the very simple information about the functionality of the monomers. Okay, functionality mean the number of reactive sites or binding sites in a monomer is called functionality of the monomer. Next, third classification based on the tacticity. So here tacticity mean the arrangement of atoms or groups on backbone of the polymer chain is called tacticity. So this based on the arrangement of atoms or groups on backbone of the polymer chain, the tacticity can be classified into three types. They are isotactic polymers, syndiotactic polymers and atactic polymers. See here atactic polymers mean. So here I am going to explaining the tacticity of polymers with one example, that is polystyrene. So this polystyrene is made up of with the monomer of vinyl benzene. So this is the structure of polystyrene. So here in this polystyrene, here we can observe the phenyl structures. Here you can see in this here in the backbone of the polymer chain, the arrangement of phenyl groups are arranged randomly. So that's why this type of tacticity is known as atactic polymers. Atactic mean the random arrangement on backbone of the polymer chain is called atactic polymers. And next one, syndiotactic. Syndio mean alternative. The arrangement of atoms or groups on backbone of the polymer chain is alternatively. Now here you can see in the example, the phenyl groups are arranged randomly, arranged alternatively. Here we can see one phenyl group should be present right hand side and another one is left, again right and left. Mean the arrangement of the various functional groups are atoms on backbone of the polymer, they are arranged alternatively. And next one, isotactic. Iso mean similar, mean the arrangement of atoms or groups on backbone of the polymer chain arranged similar or same side is called isotactic polymers. Now here we can see all the phenyl groups should be present, the same side of the polymer chain is called isotactic polymers. And next classification based on the monomers. So based on the monomers, the polymers are again classified into two types. They are homopolymers and heteropolymers. Homo mean identical or same. So here the polymers which are made up of with only one type of monomer or same type of monomer is called homopolymers. The examples of homopolymers are polyethylene, polystyrene, another example PVC and Teflon. The Teflon is made up of with poly tetrafluoroethylene, mean the monomer unit in the Teflon is tetrafluoroethylene molecule. And the next one is heteropolymers. Hetero mean different. Heteropolymers are also known as copolymers. Co mean two different monomers. Mean these polymers are made up of with two different type of monomers are called heteropolymers. Now examples of heteropolymers are nylon 66, Decaron and bakelite. So bakelite is made up of with the monomers of phenol and formaldehyde. And next another classification Based on the synthesis, the polymers are again classified into two types. They are addition polymers and condensation polymers. Now first one, addition polymers. These polymers are formed by the combining of monomers without any elimination of atoms or groups are called addition polymers. So here I am going to show the some examples of addition polymers. The polyethylene polymer is going to made up of with ethylene monomer, and the second example is PVC, polyvinyl chloride. It is going to made up of with the monomer of vinyl chloride. And next one is Teflon, also known as polytetrafluoroethylene, and this polymer is going to made up of with tetrafluoroethylene molecule. Second one, condensation polymers. So these polymers are formed by the polymerization of monomers with the elimination of small molecules. When during this formation of polymers, some of the byproducts are going to forming in this reaction, like ammonia or water or alcohol is going to forming as a byproduct. Now here I am going to give some examples of condensation polymers. They are nylon 6, nylon 6,6 and bakelite polymer. So bakelite polymer is made up of with the combination of formaldehyde and phenol monomer units, and the nylon 6,6 is going to formed by the monomers of hexamethylene diamine and adipic acid, and the nylon 6,6 is going to formed by the monomer of caprolactam. So this is the condensation polymers. So with this I am going to concluding this session. Thank you.